All right, number 7 wants us to use synthetic division to determine if the value of k is a 0 for the polynomial. So when they give it to you in this setup, the k equals 3. That is your box number. So I'm going to go ahead and start setting up for synthetic, and synthetic will be easier. So I'm going to plug the 3 over here in our little half box, and then we are going to write down our coefficients. So we have a 4, 3, 2, 1, and then 0. So we have all of our terms. So my first coefficient on the x to the 4th is a 1. And then the next one is a negative 7. And then negative 5. And then a positive 64, which I'm just going to write 64. And then a negative 39. Okay, so I'm going to draw my line. Now, the way that we determine if 3 is a 0 is that at the very end, our remainder, the last number we get, should be a 0. So if this number is 0, then that means 3 is a 0 of the polynomial. So you bring the first number straight down. 3 times 1, you get 3. And then you subtract, because different signs, you get a negative 4. And then you do 3 times negative 4, that will give you a negative 12. Combined, that gives you a negative 17. 3 times negative 17 will give you a negative 51. Combine these, and that will give you a positive 13. And then 3 times 13 will give you a positive 39. And then when you combine those, you get 0. So since my last number is 0, then that means that, yes, 3 is a 0. All right, so number 8 wants us to use synthetic division to determine the value of k, which is equal to negative 4i. So again, we will use synthetic. And then remember, as I was trying to mention in one of the synthetic division problems, if we get an I squared, that is equal to negative 1. And we will have to use that principle and reduce sum. So I squared is equal to negative 1. So in our box, our number is negative 4i. That's our little half box number. Are we missing any terms? So they have it, it looks weird, okay, but they're trying to show you that everything is there. So you have your x squared term, so that's 2. Then we have an x, which is 1, and then 0x. So they're putting it like this because it will look weirder when you have like 5 terms here. It looks like you have extra terms, but they've kind of factored it so you can kind of see what's going on. So I'm going to write them down. I'm actually going to distribute that negative throughout here, and then I'm going to write those as grouped together as well. So my leading coefficient on my x cubed is 3, and then I'm going to distribute that that negative throughout. So I'm going to write a minus 4, and then distributing the negative, this negative to the minus 4i, that's going to become a plus 4i. So plus 4i. And then my last one, since it's a positive outside, I don't have to distribute that. This is just going to be 32 minus 16i, minus 16i. Okay. So this is like a term, and this is a term together. So I'm going to bring down my first term, which is a 3. And again, we want to know if it's a 0. So again, my last, whatever I get in this last box should be 0. Negative 4i times 3. That's going to give us a negative 12i. You're going to line that up with the term that it resembles a negative 12i. You can't combine it with the 4. And then we're going to combine these terms. So 4 doesn't have a number that it matches with, so I'm going to bring down negative 4. And then I'm going to combine these and bring down a negative 8i. All right? And then we're going to distribute or multiply both of these by negative 4i. So negative 4i times negative 4 is going to be a positive 16i. And then negative 4i times the negative 8i, that's going to give you a positive 32i squared. So let me write that here. 32i squared. Now recall I squared is equal to negative 1. So this is 32 actually times negative 1, which equals negative 32. So that's what I'm going to write right here, negative 32. When I combine those, we get 0. When I combine these, we also get 0. So my last box is 0. They both would have to be 0, I guess. I should have done one big box. It's all one term. So since I got 0, then negative 4i is a 0 of this polynomial.